see my screen?
Yes, I can.
Yep, looks good.
Okay, great. So, thanks for inviting me here and NIM's introduction. As Joe mentioned, SIMCA is one of the agencies started the ActivitySim implementation. So today I'm going to talk about SIMCA's ABM project and where we are with the ActivitySim implementation. So usually SIMCA has a major update for its regional travel demand model every 5 years, aligned with the region's socioeconomic data forecast cycle and the SIMCA's long-range transportation plan development. In 2019, after many years of consideration, SIMCA decided to advance its trip-based model to an activity-based model. By the end of that year, SIMCA kicked off the ABM development project. The project duration is 2.5 years, so it will be completed by June of this year. Hopefully we'll make it ready for SIMCA's next transportation plan development. So previous trip-based model update was completed in 2017 with a model base year of 2015. So for this ABM project, due to COVID-19, we decided to set the model base year as 2019 instead of kind of a regular 2020. The key data items used for the model development include a household travel survey conducted in 2015 and an onboard transit survey conducted in 2019. SIMCA developed a full set of 2015 traffic counts, which was used for the previous trip-based model updates. Due to COVID again, we were not able to connect the 2020 traffic counts as we planned. So the 2015 traffic counts are still the primary counts used to validate the ABM. However, additional counts connected between 2017 to 2019 by Michigan Department of Transportation will be also included for this ABM validation. We have two project goals in mind. One is more general. The developed activity-based model must be practical, functional, and usable. What it means is the model must be fully calibrated and validated using SIMCA's local data. The model's runtime needs to be reasonable. Ideally, we hope it's kind of under 17 hours. Usually we say, we submitted our model in the afternoon, then next morning, we are able to see the results from the model. Also, the model needs to be well documented for both technical and non-technical users. Another project goal we have is the developed model should be capable of addressing key policies of interest for SIMCA's planning needs, such as roadway scenarios, new land use development, travel trends, transit fare policy analysis. Since this is SIMCA's first ABM, SIMCA was taking a two-phase approach. The major purpose is to get SIMCA's ABM up and running quickly. Then the project team can use phase one model to assess its strengths and weaknesses to inform phase two development. In addition, SIMCA staff can use it as a learning platform to get hands-on experience on how to operate the ABM with SIMCA's local data. Phase one development includes model design, data preparation, and initial ABM deployment. It was completed 1 year after kicking off the project in 2019. So it's around October of 2020, we had phase one model. Based on the information from phase one model assessment, phase two development includes an unnecessary model enhancement, more thorough model calibration and validation. It was estimated for another 1.5 years to complete. Right now, it's getting close to a final calibration and validation stage. As you know, ActivitySim is a dollar model for SIMCA's ABM development. Joe did a great job to explain ActivitySim, so I'm not going to repeat here. I want to talk about why SIMCA chose the ActivitySim then. SEMCA had been keeping an eye on the ActivitySim development project for several years. The general concept of ActivitySim project was appealing to SEMCA, like open source, pool funded, taking practical approach for the development priorities. And we think the ActivitySim structure can meet SEMCA's basic planning needs. And we also can learn from our peers for their advanced ABM knowledge and experience. We also think the cost saving for the model development is not only for now, but also for future, since we can take advantage of other agencies' model development efforts in long term. So for all these reasons, we decided to choose ActivitySim as a dollar model. SEMCA ABM phase 1 is a direct transfer from ActivitySim MTC one zone example with minimum changes to enable it to work with SEMCA's local data and integrate with SEMCA's regional model. SEMCA model area covers 7 counties in southeast Michigan, including city of Detroit. We have total 1.9 million household and 4.7 million population. The model area is divided into 2,900 traffic analysis zones. So when we had our completed phase 1 model, the model is able to run under 14 hours with 3 feedback loops. The computer used to run the model is a dual Intel machine with total of 12 cores at the clock speed of 3.2 gigahertz and 128 gigabyte RAM. The for 100% sample, ActivitySim takes a bit over 4 hours and total 8 hours for the all 3 feedback. We compared the base year model result with survey data. Most of them look okay, except a few things. I will mention some of them later. So besides checking the reasonableness of a base year model, the project team also conducted 3 sensitivity tests to evaluate how the model responds to various input changes. One is shifting the household income along a major transit corridor to see the impacts of demographic changes. Another is adding a new commuter rail between 2 major cities in the region to see the impacts of roadway changes. The third one is looking into the traffic impacts of a new land use development. I will talk in more detail and show a few of model results from each of these examples in next few slides. So we choose one of the major transit corridors. It's called Woodwood Avenue, to select the household for the income sensitivity test. The Woodwood Avenue is around 25 miles between Detroit downtown to the city of Pontiac. Many transit lines running along part of this corridor. The household income is being changed for all the households located in a 1 mile buffer area of this corridor. So each scenario either shift the household income down or up for 50% or 25%. So we total have 4 scenarios. The model results from all these 4 scenarios are compared to the base case. This slide shows the results from the auto ownership model. So red and blue bars represent 50% and 25% income decrease. Gray and yellow bar represent 25% and 50% household income increase. So from this graph, you see if the household income decreased 50%, that's a red bar. The zero auto household increased more than 30%, and the 4+ auto household decreased 20% compared to the base case. On the other side, the impact of increasing 50% household income, that's a yellow bar, is relatively smaller. The zero auto household decreased 50%, while 4+ auto household increased more than 10%. So other scenarios kind of fall between. This slide shows two comparisons from the same sensitivity test. One is we are looking at regional boardings. The changes of these four scenarios are between 4.5% increase and 2% decrease for these four scenarios. When we look at one of the Woodward transit lines operated by City of Detroit, D.4, we see more concentrating changes. The percentage difference is more than double compared to the regional difference for each of these scenarios. You probably see the bar same, but look at the scale is different. So in these two graphics. For our second sensitivity test, we choose the one of adding a commuter rail between two major cities, City of Detroit and the City of Ann Arbor. That's probably around 45 miles distance between these two cities. The reason for that is Simca region has gone through its feasibility study many times for this commuter rail. We thought it's a good sensitivity test to this AVM also. So a commuter rail was coded to the transit network system with a total of 6 stations. The heat will vary by time of day, mostly operating hourly during morning and afternoon peaks. The transit fare is station-based, $1 per station. During this scenario test, several parameters being adjusted. One of them is a transit transfer penalty. For this familiar with model, we use that as one of the parameters to build a transit path. It's changed from our previous trip-based model, 3 minutes to 10 minutes to prevent too many transfers. The other parameter we changed is the wait for the initial wait time, and the transfer wait time changed from 2.5 to 1.5. So the top graph summarizes the boardings by access mode for this corridor. Blue shows the numbers of westbound from Detroit to Ann Arbor. Most of the commuter rail riders are transferred from another bus. You see the middle part here, walk transfer on. That's a transfer from another bus. The share is close to 60%. But we also have quite a bit using drive access to this commuter rail. So if we look at green, green is the east direction from Ann Arbor to Detroit. Transferring from another bus still has the highest share. Direct walking, that's this green bar, comes the second. It's we have 40%. It's direct walking to the stations. The bottom graph shows more detail of each access mode share by each station. So we could look at more detail, examine the land use and the mode share is at a reasonable amount. We also look at total boardings by each station. We have, remember, we have 6 stations. Most of the westbound riders get off at its landing and Ann Arbor station. And most of the eastbound riders get off at Wynn and Detroit station. The total boardings of both directions, if you added them together, is close to 2,000, which seems aligned with our previous analysis. Though the estimated numbers for our commuter rail planners, they always think we underestimated the numbers, even though we don't know what is the exact number in the future. So the third sensitivity test is a new land use development at the Coketown neighborhood, which is one of the historical Detroit's historical districts located at the south of downtown Detroit. The scenario test represents Ford Motors Coketown development, renovating Michigan Central Station. The former train station will house members of automakers' electric vehicle team. The Coketown area is represented by the model zone 238. The scenario models additional 5,000 professional employees being added to this zone. There are no other changes made to the model, so we didn't adjust workers in any other zones. So we just simply added 5,000 professional employments to the zonal employment data. This slide showed the results from a location on destination choice model related to the zone 238. The reason you see the difference for the number of persons working at zone 238, you don't see the total 5,000 persons working at that zone. It's because in same land use data, there's over 30% more employment than workers due to various reasons. We have a footnote here to explain that. So the regional employment data is scaled back to match the total regional work numbers. That's why you see these over probably 3,300 persons working at that zone. So if you divide these additional travels by the total persons working at that zone, each additional person working at that zone produce around 0.8 tours, 2.4 trips, and 0.12 intermediate stops each day. That seems reasonable also. Tour purpose model, that's a graph from a tour purpose model, showed most of these additional tours are either work tours or at work tours, since we only added employment data. So it seems reasonable. All these additional tours more related to work. So the numbers showed in these slides are the traffic volume changes in thousands. Red is volume increased and blue is volume decreased. When we look at the traffic impacts, the biggest changes are happening to nearby local streets and two freeways, west part of I-75 and south part of M10. That means the majority of workers are from west and the south part of the region. These are consistent with existing commuter patterns we observed in the region.
Jilan, this is all very interesting. You have maybe a couple minutes, hopefully, to start wrapping up. And then I believe there will be questions for you.
Yeah, only 2 slides left. Hopefully I can wrap it up quickly. So they just list some of the phase 2 development. We have, as we say, we have more estimation for calibration and validation. We also enhanced the phase 1 model by addressing travel for University of Michigan. That's one of the issues reviewed in our phase 1 model implementation. So ActivitySim has some limitations for university student travels, and it's being enhanced in our phase 2 model. And in coordination with the ActivitySim partners, a telecommuting model and a transit pass ownership model also being added to the phase 2. We also increased the tempo resolution from 1 hour to a half hour, and we also added microzones to our 1 zone layer. So now in phase 2, it becomes a 2-zone implementation. As always, we need to build staff capacity. That's some challenges. So as we are happy with where we are with our first ABM development and appreciate all the supports we have been getting from ISG project team and the ActivitySim communities. With that said, we know we have lots of challenges, workload, commit staff time, takes more time to run ABM, perform scenario analysis. We might need consultants support. And I like the last sentence. When you think you're done, it's time to do it all over again. I think that's all I have. Hopefully there's still time I can take questions.
Yes, of course. Questions for Jilan. So while others coming up with their questions, I do have one for the land use sensitivity test scenario. Are you integrating with your UrbanSim model? I am aware that SimCog has been running the UrbanSim land use model for a long time, decades probably. Are you integrating that or just purely on the travel only ActivitySim side, making land use change assumptions?
Yeah, good question. We're always thinking we need to integrate two models together, but for now we haven't. It's a one way. We just use a land use model to provide the inputs to ActivitySim. And for that land use scenario, we just added a 5,000 employee in the ActivitySim, not making any changes to land use model.
Okay, that's very helpful. Let me see. I do have another question of mine is you're talking about the running time for ActivitySim take about 14 minutes. That's including essentially the full process, including ActivitySim and scheming and assignment. So what is the assignment model you're running? Are you running a DTA or is just a static assignment?
It's a static assignment. We have a 5 time period. So we aggregated the OD metric from ActivitySim, then divide into 5 time periods to run. Yeah.
I have a chatted question about how do you use the 2015 household survey? I probably need a bit of clarification on that one, but maybe Jilan, if you want to ask that question yourself, you can unmute yourself. Okay, maybe I will move on to ask you the next question first, as Jilan either typing or unmute him or herself. So the next one is, do you include the cross-border trips between US and Canada in your model, I suppose?
It's included in our regional travel model, but it's not adjusted by ActivitySim. Right. So we have a simple external model in our regional travel model. It's just using traffic counts like entering our region or exiting our region to control our model totals.
Mm-hmm. Okay, I think we are ready to move on. Thanks, Jilan, for a great practical kind of reflection on your experience of adapting or testing and adapting ActivitySim. Already move on to our next presentation by Joel and David that is talking about from one of the developers' perspective, what are the unique features in the ActivitySim, saying UrbanSim for too many times. So ActivitySim implementation of ABM model. With that, Joe and David, take it over.
Okay, let me share my presentation here.